Okay, so today I'm answering questions about probability. So from the homework packet, the probability review packet for the final, I had a question about number, which one was that? 14. Number 14. Would you read me the question so I can write down the important stuff?
Find the probability that three tosses of a coin
Results in exactly what? Or two tails? Alright, so everybody please get to number 14 right now. And there were two different ways to do it, and I want to see what way you did it. Okay? How many of you did it by listing out like heads, heads, tails? Heads, tails, tails. Heads, heads, heads. Raise your hand if you were that kind of kid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's about half of you. What did the rest of you guys do? If you didn't do like a list of heads, heads, tails, that kind of stuff, tails, 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 then what other way is there to do this problem? A bracket, like a parentheses, like this kind of thing? Oh, a tree diagram. Okay. That would work too. So a tree diagram, we'd be like going, okay, as a heads or tails for the first flip. And then the second flip, heads or tails, heads or tails. Third flip, heads or tails, heads or tails, heads or tails, heads or tails. Good. That's another way you could do it. You have another way yet. All right. So that anytime something is, it's called binomial, I think is what you're talking about. Is that one of these deals? Okay. No? Okay. So then, I'll show you all three ways that you could answer this question. First of all, I could make a list of all of them. And how many are there? Well, there's two choices for this, two choices for this, and two choices for that. And I'm multiplying them all together, and I get 8 total things that could happen. So I've got a list of the first two here. I'm going to go some more. Heads, 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 of course, is an option. Heads, tails, heads. Tails, tails, heads. Tails, tails. I already had tails, 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 so that one won't work. Sorry, tails, heads, tails. Let me think. I got 3 that start with heads. There should be 3 that start with heads. There should be. Oh, there's one more that starts with heads. Heads, tails, tails. There we go. And then there's one more that starts with tails. Tails, heads, heads. That's it. Okay, so there's my 8 things. Now, it's a probability, right? Probability is always what you want over what's possible. There's all the things that are possible. There's 8 things, so we put it out of 8. What do I want? Exactly 2 heads or exactly 2 tails? Does this have what I want? Yes, it has exactly 2 heads or exactly 2 tails in this case. Does this have what I want? Yes. Does that have what I want? Yes. That have what I want? Yes. Does that have exactly? No, it doesn't, because it's got not exactly 2 heads or tails. It's got 3. This has what I want, and this has what I want. So there are 1, 2, 3, 4, 5, 6 that I boxed in there. 6 out of 8 is my answer. And that equals 3/4. You know, if you didn't do it that way, if you did it with the tree, you could do it that way. It's a lot longer. Heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. And then I have to find the probability of each of those things. Well, heads, heads, heads is is half times half times half, which is 1 over 8. And the probability of all of them would be 1 over 8. 1/8, 1/8, 1/8, 1/8, etc. And then which ones are the ones I want? I would go through and find ones that have exactly 2 of things. That'd be kind of like this other one where I was circling them, you know, like over here. So heads, tails, tails would be another one that I would want. Heads, tails, heads, that one would work. And so I would just go through and circle all of them and add them all up, and there are 6 of them. Okay, so that's the fastest one I think would be this one, which was I'm going to do 3 tosses and I want 2 tails. And this is heads and this is tails. And the probability that's 50-50, and I would want 2 heads and 1 tail would be one option. Or I do the other one, 3 choose 2, but this is going to be 2 or 1. I think I could think of it this way. If I'm thinking of it in terms of heads, I want to say I want 1 heads and 2 tails. So that would be 0.5 to the 1 and 0.5 to the 2. And why did I say or? Because either this way works for me, because that's got 2 heads and 1 tail, or this way works for me, or. And notice I would add them then. So if none of these 3 are super easy, so pick what you want. But that's a kind of a good demonstration of probability because it shows you trees. It also shows you just making a list. And it also shows this, which is called binomial probability. All right. The quiz you're going to have in a minute in class in the Schoology it's not super easy. Okay, so pay attention here. You want to get your brain warmed up here first. All right, you're next. How do you what?
15.
Number 15. Would you read it for me, please? Probability of tossing 4 coins and what? At least 2 tails. All right. Can you picture I could do that same exact thing? I could make a chart, a big chart, or I could make a list of all the different things I could get, but this time there would be 4 coin flips, so it would be 2 times 2 times 2 times 2, which would be 16 things that could happen. So this time, even more, I'm thinking maybe I'd like to do one of those C things. How many? What goes in the front? 4. Choose, and at least 2 tails. If I'm talking about tails, and this is heads, if I'm talking about tails here, if I put in a 2 here, that's saying I have 2 tails and therefore 2 heads. 2 tails, 2 heads, there's a 50-50 chance of each. But isn't there more than one way that would work for this? Yes, so I'd say, or I could say 4 choose 3 tails. This is pretty easy. Do you know what to put here and here then? 3 tails and 1 heads. You get what's happening there? Or what else would make me happy if I got 4 choose 4? I got all 4 of them were tails. 0.5 to the 4, and this 0.5 is to the 0, which really means that this, you don't even need to do this part because that would just equal 1. Okay? So if it says at least, then I'm going to add up stuff. This or this or this. There's 3 different things I could add up. Add them all up, then I got my total. That was a tough one. Seriously, I bet if you poll math teachers who don't teach probability, more than half of them would get this wrong. These are tricky. Are there any others that you'd like to ask about that you had trouble with on 1 through 18? Did you get that binomial thing I just did? Because you're going to need that. And if you need more practice on that, I can do that again. All right, I'm going to do one more like that. Everybody get a blank page in your notes. Add a page. Just add a page, and I'll know that you added it because I told you to. Let's say you are a 85% free throw shooter. 85%. So that means if you make it 85% of the time, what percent of the time do you miss it? 15. All right. I want you to just write me the probability that if you get 3 shots at the end of the game, what's the probability you will make 2 and miss 1? Do one of these deals. You're going to make 3 shots. You're going to make 2, miss 1. You just make one of them makes and one of them misses. Then you go, how many do I get? 3. And the first thing you list right here, that should be this number right here. 2 makes. Okay, so then what's my make percent? It's right here. They gave it to me. What my miss percent be then? Must be 15 because it has to add up to 100. And then I want to make 2 and miss 1. How many of you wrote that down? And you did it right. Okay? But what if I change it to make at least 2? Then I could make 2, or you get that I would add another one to that, and I could make 3. 3 choose 3. 0.85 to the 3, 0.15 to the 0, because these two have to add together to make 3. Alright, so then you just add those two together and you have your total. That's probably the hardest kind that there is. You times it by 3 choose 3, which is actually just a 1. And 1 times this. Somebody might say, well, couldn't I just have done 0.85 times 0.85 times 0.85? Yeah. But that doesn't work for all these kind. These are harder than that. Yes, ma'am? Yes, everybody please turn to number 2, C. Would you read me that problem? Probability of a randomly chosen student will do what? Or enjoys evening class. All right, so we have to look on our chart. First of all, since it said random student, that means it could be out of anybody. It doesn't mean only seniors. Okay, so then how many, on the chart, how many does it say is the total? 129, so it's out of 129. And then what do we want? We want people that are seniors. How many of those do we have on the chart? 38 seniors, okay. 38 plus, we also need people that enjoy the evening classes, but make sure you don't count seniors because we already counted them before. You know what I mean? So take all your evening class people, but subtract off the seniors, which I think, if I remember right, was 7 seniors that liked evening classes. So how much are the evening class people that are not seniors, because we already counted them? 21? 31? Okay. All right, so there. Does that look right then? Okay. Just add the top numbers, divide by 129. All right. Is there any others? I'd be glad to explain more. Yes. Okay, read me number 6. All right, to do this one, I need it's a Venn diagram, right? So what are the 2 categories? Sports and then sophomores? Is the first one sports? Okay, soph and then sport. What is the number underneath soph? How about in between in the overlap section? The sport one. And the not included. All right. Now, as soon as it said, given that the student is on a sports team, do you get that I only can use these 2 numbers and I cannot use those? Because when they say given that they're on a sports team, those are the only things that are possible, the ones I circled there. So remember, the probability is always a what you want over what's possible. What's possible is these 2 things added together. And so I got to add 0.075 plus the 0.145. Those are the only things possible. And what I want goes on top. And what do I want? A sophomore. What is the probability of a sophomore? So a sophomore is what I want, and that's only this part. So that's the 0.075. So if you took that divided by those two added together, you'd have it. Okay? All right. So is there anything else from the packet that was confusing or need talked over? Okay then. The rest of the assignment is same kind of stuff. We've already talked about the hardest part of probability. So today you're just going to have a day where you work a little farther on probability. You're going to have 12 more questions. It makes a total of, I think it's 30. Do all the probability questions in the packet, but that's all you do tonight. Okay? And then tomorrow we'll start on other stuff. So today you have the rest of the hour to finish the little 12-question quiz on probability. It's in Schoology. And notice that every answer is supposed to be a decimal rounded to 3 places. So like 0.175. And if you round wrong, it will be wrong. And if your answer is supposed to be negative, I think one of your answers is supposed to be negative, make sure that you include a negative sign in front of the number. You don't put negatives at the end, you put them in front of the number. And then you can just finish the probability packet. Probability part of the packet.